Section 7.2, Simplifying Radical Expressions. Many radical expressions can be simplified by using rational exponents. First, we want to convert the radical expression to an exponential expression, use arithmetic and the laws of exponents to simplify, and then convert back to the radical notation as needed. And that's what they're asking here in this problem, is to use rational expressions to simplify, but to write our answer back in radical notation. So in this first problem, we're going to translate this. The index becomes the denominator of our exponential power. So we will have y to the 3 over 6th power as a translation from this radical to a rational exponential power. Looking now at that rational power, 3/6 reduces to 1/2, and now that it's simplified, we'll put it back in radical notation. The denominator is the index on our radical, so it's the square root, because there's no index, it's understood to be 2, of y. In this next problem, very similar, we have the quantity xy that's taking the 4th root of that, so it's raised to the 1/4 power, replaces the radical, and then it's raised to the 12th power. When you have something at a power raised to a power, you multiply exponents. 1/4 times 12, or 12 over 4, gives us 3. So there is no radical form for the simplification of this. Our final answer is the quantity xy to the 3rd, or we could raise each of these terms, in other words, the product to the power, we could say the equivalent of x to the 3rd times y to the 3rd. This next problem is asking us to simplify this rational expression. The radical is the 4th root of this quantity and then raised to the 8th power. So we have m to the 2nd, n to the 5th. It's raised to the 8th but has the 4th root, which is the denominator. The index becomes the denominator of our rational expression. Similar to the last one, we can do the division. 8 divided by 4, as you can see, means that this is equivalent to m to the 2nd, n to the 5th, raised to the 2nd power. Each of these terms then, or factors, is raised to the 2nd power. And our simplification would be m to the 2nd raised to the 2nd would be m to the 4th. N to the 5th, also raised to the 2nd, will leave us with m to the 10th power. There is no radical notation, but we have simplified the problem. In this next problem, we have the 5th root of x and then taking the square root of it. And thinking about order of operations, we work from the innermost out, and so we have to replace this radical with a rational exponent. So the 5th root of x would be equivalent to x to the 1/5, and then that is having the square root of it, which in rational exponents means it would be that quantity to the 1/2 power. Now that it's in exponential form, we can use our law of exponent. When we have a power raised to a power, we multiply those powers together. Multiplying numerators gives us 1, multiplying denominators gives us 10. We've simplified it going through exponential form, and now we need to convert it back to the radical notation. X to the 1/10th power means the equivalent of taking the 10th root of that quantity, and in this case, x. In this last example, we are taking the square root of this quantity, the radicand, which means we have xy to the 10th power. Square root means it's raised to the 1/2. So we've converted it to exponential. Power raised to a power we multiply. 10 times 1/2, 10 over 2, gives us x, y, the quantity to the 5th power. We certainly could leave it in that form, or taking that product to the 10th power would mean x is to the 5th times y to the 5th. Either one of those would be correct form of the answer.